We are now on to the part of our lecture where we want to introduce the idea of modeling. So what is a model? Put simply, a model is a representation of the real world. So here we have the real world, and I want to explain something about the real world. I want to know what causes or what can explain or predict the quantity y. Can I use a different quantity, let's say x, or can I use multiple quantities to explain what precisely happens to y if I make different changes in x? Now, the real world is a very messy world. There's a lot of noise and other things that are making it very difficult to understand just how exactly these different factors impact another factor, which we call y. Um, so when we want to understand something about the real world, obviously the real world gives us a little bit of a preview of what's happening through the use of data. Okay, that is information, right? So we get a lot of information about the real world. We observe things with our eyes, our sense of smell, hearing, but also we have other ways of observing through our eyes and through intellect, right? Through knowledge, writing things down, as well as understanding abstract quantities that we can perhaps directly observe, right? So information can come in a lot of different forms, and this is not per se an information-based class, so I'm going to reserve a discussion on that. But here's the point. Data is reflective of the real world. It's information about what's going on. I could use data to try and understand something about the real world, but again, there's a lot of noise. There's a lot of things that get in the way of trying to explain, well, why is it that some quantity y is the way that it is? For example, in our case, we might try and understand why would a consumer want to purchase our product and why might they not want to purchase our product? We might want to understand how much quantity of a particular product should we order when we don't exactly understand or know how many customers we're going to have whom will buy that product. So these are questions which are very practical, but at the same time very challenging to answer because the world is a messy place. There's just too much stuff to even get information. So what we try to do is we try to take a snapshot of the real world using some of this data, um, which is reflective in part of the real world, and we create a theoretical world. A theoretical world is a very simple, beautiful type of world. It's very elegant, easy to explain. If I if I make a change in this quantity, I'm going to see the same exact change in the other quantity each and every time. Everybody making this amount of income will spend exactly this amount of money. So theoretical models help us simplify and better understand things about the real world. The problem is, however, when we go to design our theoretical world, there is what's often referred to as error. The theoretical world is not going to look exactly like the real world because we're going through a simplification process. We're saying we're going to focus on these aspects of the real world, and everything else we're just going to, here's the magic word, assume that the other stuff doesn't matter. I don't care about the other stuff. I care about very specific aspects of the real world. So I might, for example, care about an inventory system where I want to know what impacts, how much should I order such that my total amount of costs are at a minimum. And the only things that I might care about is that I might make an assumption that my demand is known. I know exactly how much how many individuals will absolutely buy my product, right down to an exact number. I know exactly what my costs are going to look like. I've accounted for every possible cost. If I'm going to, assume that there's no such thing as spoilage or damage to my property or theft or anything like that. In other words, I'm carving out a portion of the real world to create a perfect theoretical world, which is just much, much easier to understand. When I do that carving out, I do so through by the process of what we call making assumptions. So we make what are called simplifying assumptions. We look at the real world and say, okay, here's what we're going to study. Here's what we don't care about at the moment. Yes, it's true. These things can impact what I do care about. But what I try to do is isolate my thinking and my analysis on quantities that I care the most about, knowing full well that I will get error as a result of carving out that portion of the real world. This is true of any type of science, might I add. This is true of chemistry, physics, biology, economics, and of course, in our area, business. So whenever we design a theoretical model, the first step is what specifically in the environment, in the real world, do we care about and what do we not? This comes down to subjective decision making, which is not always a perfect process, right? But that's the beauty of analytics, is that there's a bunch of different analysts who are looking at the same real world from different perspectives. One analyst may consider these factors more important than another analyst. As it turns out, there are three fundamental types of theoretical models. And by the way, remember, a model is a representation of the real world. It's a theory, basically. So what composes of a theory? Well, when we talk about a theoretical model, we have three basic types. We have what's called a conceptual model, we have what's called an empirical model, and we have what's called an analytical model. Some may go to the further extent to say we also have simulation models, but I am of the belief that simulation is a combination of all three of these. A conceptual model is just nothing more than a group of concepts, ideas, that we link together in our head. Usually we refer to these as like the nomological net, so to speak. It represents all of our knowledge and how these different aspects of our knowledge are connected to each other. So for example, in the case of economics, I might care something about, let's say, consumption, but what drives consumption? It might be age and it might be income. But we know that age and income might be related as well. And what drives income other than age? It might be education level. Education levels might also impact, may I add, the amount of savings that we have, which of course may impact one's consumption levels. So as we can see, we have these general ideas. These are called concepts. And the concepts usually come in one of two forms. They're either abstract or they're concrete. In the case of an abstract concept, we usually refer to these as constructs. For example, the idea of crime. Crime is an abstract concept. Can you directly observe crime? The answer is no. Why? Because crime is an overarching concept that is actually composed of other concepts which are concrete, which we can observe. For example, murders, rapes, thefts, frauds, etc. Okay, so as we can imagine, we have things we can observe which are called which are concrete, and we often refer to these as variables, although some authors make a distinction of these. I'm just going to leave them as variables. When they're abstract, that is, we can't directly observe it, but rather these concepts are an amalgamation of other observable concepts or non-observable concepts, then we consider those to be what's called constructs. All of these, as you can see, are concrete. They're observables. I can directly observe somebody's age, income, education, savings, and consumption. Education actually could be argued to be a construct where there's a few other things that make up the concept of education. For example, the number of years in college. It could represent the amount of mathematics education one has received, as well as reading education, and so on and so forth. So, moral of the story, this is what we call a conceptual model. It's when we identify the constructs and variables which make up a particular area in the real world that we care about. This is an example of an economic model, for example. I might design a crime model, or a political model, or a psychology model, or a marketing model, or a supply chain model, or etc. Basically, I'm looking at the concepts that make up that environment, as well as, by the way, how those concepts, or if those concepts, are related to each other. By relating, we mean if we make a change here, will we see a corresponding change here? So that's the basics of a conceptual model. From the conceptual model, however, we move to what's often referred to as an empirical model. And an empirical model is a mathematical equation that tries to connect let me write this a little bit better, that tries to connect a group of variables that I have in my environment to another group of variables in my environment. No matter how many outputs I'm looking at, I'm looking to connect all of the outputs to the same inputs, or maybe different inputs. And basically, what I'm trying to do is design the actual equation that describes the connection between these concepts. Constructs are more difficult and challenging to handle because we can't observe them, and we therefore need to make up more advanced types of equations. Observables are much easier to handle because we can just say, well, we have a number here. This is my input. That's related. It's something that's directly measurable. I can get a number for it very easily. I just plug that into my equation and I get my corresponding output. So that's the idea behind the empirical models. Usually we start with the inputs and the outputs, and we try to figure out what's the rule which connects the inputs to the outputs using the data. This is outside the scope of this course. You will learn that in a statistics course or an econometrics or machine learning course. For our purposes, though, we're going to focus on the third model, which is what's referred to as the analytical model. And the analytical model, it's the same general idea of connecting a whole bunch of different y's to different x's, but rather than starting from the x and the y, what we do is we make assumptions about the x and the y, and we start with an equation for a function. So on the one hand, I may have a whole bunch of data, okay, in x and y, and I might ask, what's the rule? That's what we call the empirical modeling process. On the other hand, I may not have X and Y data. Let's see, X and Y data. That's unknown to me, but I do have a rule that I've derived based on assumptions about the environment that I know connect the X to the Y. And what I want to know from my assumption making is, what are the properties of this function, and how can I understand what's the best Y's for given X's? So those are your three different models, types of models.